How to get better results with better RAG. Hello guys, this is a short video about a new blog post that was published by the Anthropic team, the company who built Claude, and they are releasing new findings regarding how to generate better output using a better way to do RAG. RAG is retrieval augmented generation. Basically, it's a synonym, or it's similar to, it's actually pulling or using a knowledge base. And let me go through what they are publishing in the blog post. It's very interesting, especially if you're building something a bit more complex in production level and you have a huge knowledge base. I believe you'll find this very interesting. This is a bit more advanced and technical. So if you're interested, please stick through, and if you have any questions, obviously let me know. I'll try to clarify the terms and definitions as much as possible. By the way, obviously I will leave the link to the blog post in the video description. If you're interested in this kind of stuff, please make sure to subscribe to the channel. I'm covering AI related videos and AI related content. And yeah, let's get going. So let me read through this pretty quickly, and I'll focus on what I find important. For those of you who don't know what is RAG, it's basically a method that retrieves relevant information from a knowledge base and appends it to a user prompt. So let's say you have customer support, AI bot, and you need information about the offering of your company or about shipping information. So you can just add a RAG which contains all the knowledge about the company, and whenever you have a prompt, basically the knowledge from the knowledge base is being added to the prompt. Okay, in most cases the simplest solution, they are saying the simplest solution is just adding the knowledge base to the prompt. So if your knowledge base is smaller than 200,000 tokens, about 500 pages of material, you can just include the entire knowledge base in the prompt that you give the model with no need for RAG or similar methods. They obviously also added prompt caching, which reduces the cost involved in adding like a long system prompt or just adding more knowledge to the LLM. So this is something to consider. If you don't know what is prompt caching, do make sure to read about it. Now let's dive into their explanation. So for larger knowledge bases that don't fit within the context window, RAG is the typical solution. RAG works by pre-processing a knowledge base using the following steps. So first, it breaks down the knowledge base, it's called the corpus of the documents, into smaller chunks of text, usually no more than a few hundred tokens, and you can decide to what are the size of the chunks that you want to break down the text to. There are pros and cons to different sizes. If you have big chunks, so you have more context, but it might cost more, and it also might get the model confused because you have a lot of context and some might be similar to the context in other parts of the knowledge base. So there are pros and cons to different chunks, and they mention later on what is the ideal size of chunk. After you chunk down the knowledge base, so let's assume we have a huge book of 1,000 pages and we want to chunk it down, so we just chunk it to 20 pages. So it's 50 chunks of 20 pages, just an example. So then you use an embedding model to convert these chunks into vector embeddings that encode the meaning. So basically you take the content of each chunk and you convert it to a vector, which is just a numeric representation of the content. Then you store these embeddings in a vector database that allows for searching for the semantic similarity. At runtime, when a user inputs a query to the model, the vector database is used to find the most relevant chunks based on the semantic similarity to the query. Then the most relevant chunks are added to the prompt, sent to the generative model. So let's say we took these 50 chunks of 20 pages long from the book. We created a numerical representation of each one of them. Now, let's say a user asks a specific question. We are going to scan the database to see which are the most relevant chunks to the query of the user, and then we will just add these chunks to the prompt. So we're adding knowledge to the prompt. So while embedding models excel at capturing semantic relationship, they can miss crucial exact matches. So they give an example later on. What does this mean? And fortunately, there's an older technique that assists in these situations, which is called best matching 25, which is basically a ranking function that uses lexical matching to find precise word or phrases matches. This is a bit technical, not so relevant, but this is important. So here's how BM25 can succeed where semantic embedding fail. Suppose the user queries error code TS999 in a technical support database. So an embedding model might find content about error codes in general, but could miss the exact TS999 because it finds something that it believes is relevant based on semantic similarity, but it actually isn't that precise. It doesn't recognize that we're looking specifically for this error code. So the BM25 looks for the specific text string to identify the relevant documentation. So RAG solutions can more accurately retrieve the most applicable chunks by combining the embeddings and the BM25, and it looks like this. So break down the knowledge base into smaller chunks. Then they create an encoding and semantic embeddings for the chunks. Then they use the BM25 to find top chunks based on exact matches. So they look in all these chunks for the exact things that are relevant to the query of the user. Then they use embeddings to find top chunks based on semantic similarity. And then they combine and they duplicate results from the fourth step and the third step. So basically, they create top K chunks. Top K is like you assign if you want to like the top 25 or the top 10 or the amount of chunks that you want to add to the prompt to generate a response. Now, by leveraging both BM25 and embedding model, traditional RAG systems can provide more comprehensive and accurate results, balancing precise term matching with broader semantic understanding. And this is a visual representation. So you have the corpus, the big book of, let's say, 1,000 pages. Then you create chunks. You decide what is the size of chunks that you want to create. Then you send it to embedding models and you store it in the vector database. This is the numerical representation of all the chunks. In the meantime, simultaneously, you also send it to the TF-IDF index, which is for the BM25, which looks for exact matches. Then when a user, let's say a customer in your chat support bot asks something, the query is sent to both of them. And then we have, like we mentioned here, the combination and the duplication of results. And the top K, let's say 25 most relevant chunks are being sent to the prompt as knowledge, like they are being added to the prompt. And then the LLM responds based on the data provided in the top 25 chunks, assuming K equals 25. Okay, this approach allows you to cost-effectively scale to enormous knowledge bases far beyond what could fit in a single prompt, but these traditional RAG systems have significant limitation. They often destroy context. So if you've messed around with RAG, you know that sometimes it doesn't provide exactly what you wanted, and this is what this research is trying to address. So in traditional RAG, documents are typically split into smaller chunks for efficient retrieval. While this approach works well for many applications, it can lead to problems when individual chunks lack sufficient context. For example, imagine you had a collection of financial information, let's say the US SEC filings, embedded in your knowledge base. and you receive the following question. What was the revenue growth for Acme Corp in Q2 2023? A relevant chunk might contain the text, the company revenue grew by 3% over the previous quarter. However, this chunk on its own doesn't specify which company it's referring to or the relevant time period, making it difficult to retrieve the right information or use the information effectively. So in this case, in this example, we have used the RAG, but we didn't necessarily fetch the correct part of the knowledge base because we were lacking context. Now, what they are proposing is contextual retrieval. That was hard to pronounce. Anyway, solve this problem by prepending chunk-specific explanatory context to each chunk before embedding. And also creating the BM25 index, which is basically providing contextual information to the BM25 index as well. Now, let's return to our sec filing collection example. Here's an example of how chunk might be transformed. So let's assume this is the original chunk. The company's revenue grew by 3% over the previous quarter. And this is the contextualized chunk. This chunk is from an sec filing on Acme Corp's performance in Q2 2023. The previous quarter revenue was blah, 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 and the company's revenue grew by 3% over the previous quarter. Here they're mentioning that they also tried other ways to of retrieval, which didn't work as well as the contextual retrieval. If you're interested in reading about these to expand your knowledge, give it a go. I did read them, but eventually time is a scarce resource. I want to focus on what is working best, so I prefer focusing on what they are proposing here. So they are saying, of course, it would be far too much work to manually annotate the thousands or millions of chunks in a knowledge base. So basically providing this context to all the chunks is impossible manually. So to implement contextual retrieval, we turn into Claude. Basically, they wrote a prompt that instructs the model to provide concise chunk-specific context that explains the chunk and will be added to the embeddings, to the database. So this is the prompt. As you can see over here, they're using XML tags, document. This is the whole document. Here is the chunk we want to situate within the whole document. This is the chunk content, and please give a short context to situate this chunk within the overall document for the purposes of improving search retrieval of the chunk. Answer only with the sufficient, however you pronounce it, context and nothing else. Now, the resulting contextual text, usually 50 to 100 tokens, is prepended to the chunk before embedding it and before creating the BM25 index. So basically, this is a great representation or visual representation. So we have the initial chunks or all the chunks. Then we run the prompt for all this, the chunks, and we add a piece of context to each chunk. So context 1 plus chunk 1, context 2 plus chunk 2, context X plus chunk X. And then we take all of these and we push them to the embedding models and to the TF-IDF. Basically, we are going to do a process which is similar to what we did before, querying the vector database and also using the BM25 for similarity. But this time we also provided the context to the chunks. Now they are discussing prompt caching and how it reduces the cost of the contextual retrieval. This is the most interesting part. So recommendations and findings. So contextual embeddings reduce the top 20 chunk retrieval failure rate by 35%. So this is it's actually reduced from 5.7 to 3.7. The measurement here, which they are checking, is explained right here. They just explain better than I do. So I check this out here. So wait a sec. where did they write exactly what it means? So basically, top 20, let's look it up here because I also okay, recall K. So a metric measuring the proportion of relevant items found within the top K retrieved items. So basically, this is measuring the how many relevant items were found. So it was reduced by 35% from 5.7 to 3.7, and combining contextual embeddings and contextual BM25 reduced the top K failure rate by 49%. So this is a significant reduction in irrelevant, in just better output, to be honest. So when implementing, and these are implementation considerations, which is very interesting. When implementing contextual retrievals, there are a few considerations to keep in mind. So first of all, your chunk boundaries. You need to decide how you want to split your document. So the chunk size is how many tokens are going to be in each chunk, so how many sentences, paragraph, etc. The chunk boundary is where exactly do you decide, or do you decide how exactly you are going to cut each chunk? So end of paragraph, every comma, when exactly do you pause the chunk or cut the chunk, and what is the overlap? So very often you want to overlap between chunks because you want to have the context from the recent paragraph or text, and you also don't want anything to fall in between the cracks. So very often you're going to create chunk overlap, and this can affect performance. All of these can affect performance, and it's up to you to decide what is the best, what are the best parameters. Obviously, I mentioned at the beginning, this is more advanced. This is something that you need to evaluate and need to like really run a lot of tests until you get it right. But it's interesting and important for anyone who is interested in LLM. So let's keep going. And obviously, if you want to implement it, you need to test and experiment. The embedding models also matter. So there are different ways, different embedding models, and they work in a different manner. So they produce different output, and this is something to consider as well. They are recommending the Gemini embedding model. Another thing to keep in mind, another variable in this equation is the context, custom contextualizer prompt. So they gave a generic prompt, like I showed you before in the XML. You can change the prompt, and based on this, the context added to the chunks is going to be different and might be more relevant or less relevant. So also something to keep in mind. And the number of chunks, so adding more chunks into the context window increases the chances that you include the relevant information. However, more information can be distracting for the models, so there's a limit to this. And they tried different chunks, and they found that using 20 is the top performing. So when the context window becomes larger, intuitively you say, okay, more context I provide is going to be better. But the thing is, LLMs sometimes, when there is a lot of context, they get confused and they don't know, it's distracting, they don't know to distinguish what is important and what is less important. So this is why the number of chunks is important. Now, this is another interesting thing that they did. And what they did here, they added another layer of reranking. So reranking is a commonly used filtering technique to ensure that only the most relevant chunks are passed to the model. Reranking provides better responses and reduces cost and latency because the model is processing less information. And these are the steps. So first you perform initial retrieval to get the top potentially relevant chunks. So they used the top 150 chunks. Then you pass the top end chunks, in this case 150, along with the user query through the reranking model. Now, the reranking model gives each chunk a score based on its relevance and importance to the prompt, and then they selected the top 20 chunks, and only afterwards they took the top 20 chunks into the model as context to generate the final result. And this is the visual representation. So let's make this bigger. So you have the corpus, then you have the chunks. You run the prompt to create context to each chunk. Then you do the embedding, you do the BM25, you have the query of the user, you do the deduplication from the results of the vector database and the BM25. Then you push 150 results into the reranker. The reranker spits out only the top 20 or top K, whatever you decide. And these are the only chunks that are added to the prompt, to the LLM. So, and based on these chunks, the LLM is going to respond. Over here, they are sharing more performance measurements of checking different re-ranking solutions. The top performing solution is this one, Cohere re-ranker. I didn't even know about this before learning about this, reading this blog post. So I did some learning about this. Looks interesting. Might be a bit of an overkill for most of you. And let's see anything else. I think that was pretty much it. Let's see the conclusion. So embeddings plus BM25 is better than embedding on their own. Voyage and Gemini have the best embeddings of the ones we tested. Passing the top 20 chunks to the model is more effective than just top 10 or top 5. Adding context to chunks improve retrieval accuracy a lot. And re-ranking is better than no re-ranking. When you stack up all these benefits to maximize performance, we can combine. Okay, this is basically what you want to do, exactly the process that you want to follow. It's right here. And I guess that's pretty much it. Over here, they show the results. If you're interested, make sure to check out this blog post. They have more links and more information in this blog post. That's pretty much it. So my takeaway from this is, first of all, it's very interesting to see how just adding more layers, and we see this also in the chain of thought in the new OpenAI model, the O1, how using more iterations and validations usually is going to create better output. On the other hand, you don't want to create too much overhead and make the process too complex, because then you have more costs and higher latency, and obviously things can go wrong with just creating confusion or distractions. So it's always a matter of trade-offs, and you need to figure out what is most suitable for your use case. What else? I guess that's pretty much it. It's just an interesting research regarding how can RAG be improved. I always like seeing what these companies are researching. Obviously, most of the stuff is kind of irrelevant for my use cases and for like the general population, but still, it's very interesting to see how they are pushing the envelope and how technology is evolving. I guess that's it for today, guys. If you enjoyed this video, obviously like and subscribe. If you have any suggestions, ideas, please leave them in the comment section. And until next time, keep on automating.